It's undeniable that climate has varied from warm to cold and back again many times over the history of the Earth. However, it's also undeniable that carbon inputs to the atmosphere from human activities are warming the climate at an alarming rate. Ocean acidification is an indicator of this and is causing numerous ecological problems. When discussing anthropogenic climate change, we often hear about how the warming climate is causing sea level rise. However, an equally damning result of climate change is the acidification of our oceans. Acidification is a result of pH changing from higher to lower levels. Carbon turns into carbonic acid when carbon dioxide mixes with ocean water. This reduces the number of carbonate ions in the water column, making it difficult for many ocean life forms that rely on these ions to develop. This in turn leads to a collapse in the food chain, because other larger marine life depend on these smaller life forms. The oceans are facing a major reduction in biodiversity with anthropogenic climate change. Ocean acidification is a symptom of climate change. Anytime water and air meet, there is an exchange of gases. Gases in the atmosphere are absorbed into the ocean, and gases dissolved into the ocean are released into the atmosphere. If the ocean and atmosphere are in equilibrium, almost the same amounts that are absorbed are released back into the atmosphere. Humans have pumped over 365 billion metric tons of carbon into the atmosphere since the beginning of the Industrial Revolution. In addition to this, deforestation has added 180 billion tons of carbon to the atmosphere. 9 billion more tons are added each year. This means that CO2 in the atmosphere is higher than it has been in the past 800,000 years, and possibly even longer than that. Oceans have absorbed 150 billion metric tons from human carbon outputs, or a third of the carbon in the atmosphere from humans alone. The oceans are receiving 2.5 billion tons of carbon yearly from the atmosphere. The graphic here shows the exchange of carbon between the atmosphere and the ocean. The pH of the ocean has dropped from 8.2 to 8.1 in the past 200 years. Because pH is logarithmic, this means that oceans are 30% more acidic than they were in the year 1800. At the rate that carbon is being added to the atmosphere, our oceans will drop to a pH of 7.8 by the end of this century, meaning they will be 150% more acidic than they were in the year 1800. The graph here shows ocean pH levels over the past 400 million years. Ocean pH is lower today than it has been in nearly 100 million years and is predicted to continue to fall. This is attributed to anthropogenic climate change. Historic data show that during times of excess carbon in the atmosphere, the ocean did not experience acidification the way that it is today. This is because during these events, the rise in carbon in the atmosphere happened gradually, more gradually than it is today. Other geophysical processes were able to help to counter ocean acidification by acting as carbon sinks, such as the absorption of carbon by rock, for instance. This is a major indicator of anthropogenic climate change. At no point throughout history has the ocean suffered as much as it is today due to current carbon in the atmosphere. In this chart, you can see the correlation between a rise in atmospheric carbon to ocean carbon and decline in ocean pH. Ocean acidification is a canary in a coal mine for climate change. It is a major telling sign that humans are increasing carbon in the atmosphere drastically.